So, lock and key problem. We'll talk about a counterintuitive lock and key problem. So, the question is that we have a lock, one lock, and we have 10 keys, out of which only one is the correct key, and we do not know which one is the correct key. So we try out each key and then we throw it away if it is not the correct key and try the next one. So I try at random. Every time I try one, I know it's the wrong key, so I throw it away. So the, the question by intuition would mean that the chances of getting it right on the first attempt should be 1 out of 10, and then since you threw away the chances of getting it right the second time should be 1 out of 9, 1 out of 8, and so on. But let's try it mathematically and see where we get. So what's the sample space of this situation that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 keys, and any one of them, let's say number 10 is the correct key. So what sort of combinations what is the sample space? Now these 10 keys can be arranged 10 factorial ways, because you can try one and then the second number of key might be the correct key, but this one can be any of these 9 and then the rest can be of any of these 9. So this is not just 10 ways which you can arrange it, it is 10 factorial ways that you can arrange it. So what are the probabilities of one particular arrangement? That would be 1 over 10 factorial. And what is the probability that I will succeed in the first try? So the probability of the success happening in the first try is, say, 1, because there is only one correct key. But then there are 9 factorial ways in which you can arrange the other 9 keys. So that is 1 times 9 factorial divided by 10 factorial, or 9 factorial divided by 10 factorial, which is basically 1 out of 10. So it's the same answer that you can get, which you can do by intuition. But let's try what happens when you do not succeed in the first try. So now the question is, what is the probability of getting it right the second time? What is the probability of getting right the second time? So here, the first you pick from any of the 9, but its position is fixed, it doesn't vary. So that's why it's not going to be factorial, it's just 9 possible numbers that you can pick. In the second round, you pick the right one, which is only 1, but in the third number, any of the 8 factorial combinations can come in, and the total possible is still 10 factorial. So that essentially becomes 9 factorial divided by 10 factorial, or 1 out of 10. The third time, in the similar way, it's going to be 9, then 8, then 1, then 7 factorial divided by 10 factorial, or 1 out of 10. So this seems counterintuitive to what we had thought of earlier, that as you try, your chances should improve. The chances of success in each try still 1 out of 10.